morning students, myself Sushmita, Assistant Professor, EC Department RCET. So in this video we will be learning about antenna parameters. So on completing this particular video you will be able to understand what are the different types of antenna parameters and how radiation mechanism works in antenna as well as the radiated power in antenna. So first let me explain you about antenna. So what is antenna? Have you ever seen antenna? Antenna is nothing but which will be converting the wave gates into that is the guided waves present in the waveguide. It will be converted into radiating waves such that it travels in free space or vice versa. You can see in the diagram in the olden days that is and 10 years before we used to use these types of antenna in our homes. That is antenna. So now coming to the radiation pattern lobes, you can see half bar beam width is calculated, and then which is the green color, that is the main lobe, as well as the full null beam width between the first nulls, and there are so many side lobes. The side lobes are also called as the radiated patterns. So now let's see some necessary condition for radiations. So there are three different types. First one is isotropic, next one is omnidirectional, and third one is directional. So isotropic in the sense you can see clearly in the diagram, whereas omnidirectional in the sense it will be radiated in all the direction, that is the antenna radiation pattern will be everywhere, radiated in all possible direction. Directional is nothing but it will be radiated in a particular direction or desired direction. Suppose if we want a particular antenna to radiate in a particular direction, then we can make that antenna to be on that focused on that particular side. That is called as a directional antenna. So next one is field regions. As we know that there are two different types of field region. One is near field region and another one is far field region. Near field or Fresnel region, it is nothing but within the radius of smallest sphere and it will be completely enclosing the antenna. That particular region is also called as Fresnel region. Whereas in far field region we can say that the region beyond the Fresnel region is called as Fraunhofer region or far field region. So these are the two different fields that we can see. So coming to the next antenna parameters, let's see it in detail one by one. So first one is radiation pattern. So what is radiation pattern? Radiation pattern is nothing but it is a plot of far field radiation from the antenna. When we can say it specifically, it is nothing but the power radiated from the antenna per unit solid angle or the radiation intensity. So how we are calculating this is we will be simply multiplying the power density at any given distance to the square of the distance, where the distance is denoted by r. So you can see that we are applying by Poynting vector, which is u is equal to r square into s. So next one is radiation intensity. Radiation intensity is nothing but in the given direction is the per unit solid angle radiated in this direction of antenna. So total circumference which can be given by 2 pi radians. So this is how it works. So next parameter is the directivity. So from the name itself you can see that directivity is nothing but function of direction. It is completely depending upon the direction of antenna. So we can say that it is defined by the ratio of radiation intensity antenna in the direction to the mean radiation intensity in all the directions. So next one is radiation resistance and efficiency. So what is radiation resistance? So radiation resistance is nothing but the power dissipated in the radiation resistance is the power actually that is being radiated from the antenna and the power that is also being lost within the same antenna itself. So how the power is lost? There may be losses either due to conducting or dielectric parts of antenna. We can say that there are two losses. So which is nothing but how in simple words we can express it as the ratio of power radiated to the power accepted by the antenna. So this particular antenna efficiency can be calculated by the radiation resistance compared with the losses. So we can say that the antenna is said to be resonant if its input reactance X of A is equal to 0. So coming to the next parameter, that is power gain. Power gain G, or simply the gain of an antenna, is the ratio of radiation intensity of an isotropic antenna radiating to the small power accepted by the real antenna. So if you don't know what is isotropic radiation antenna, you can watch in the previous slide. I have explained about radiation and that is isotropic antenna and its pattern as well. So next one is antenna gain. What is antenna gain? It is the ratio of radiation intensity in the given direction to the radiation intensity that is obtained. So if you are expecting a particular radiation intensity in a given direction, and the radiation intensity that is being obtained is called as the antenna gain. So how we can express this? G of theta comma phi is equal to 4 pi u of theta comma phi divided by p input. So this is the directivity and gain. So in specific, to define directivity, we can say that power in a certain direction divided by the total power that is radiated. How about gain? Gain is nothing but power density in a certain direction divided by total input power to the antenna terminals. So this is how we can calculate antenna gain. So next parameter is bandwidth. So bandwidth is nothing but it is the expressed ability to operate over wide frequency range. We can say that the power gain, the bandwidth is said to be maximum when the value is up to 3 dB, and the VSWR is not greater than 2:1, which is smaller. The bandwidth is usually given as the percentage of nominal operating frequency. The radiation pattern of an antenna may change dramatically outside its specific operating bandwidth. So next one is a reciprocity theorem. So we can see in detail. So what is a reciprocity theorem? If a voltage is applied to a terminal, that is, we are having an antenna and it is having two terminals A and B, then how we will be measuring the current or voltages? We will be measuring the current that is being generated across those two terminals, which is again equal to the current that is obtained at the terminal A if the same voltage is applied to the terminal B. Next one is effective aperture. So effective aperture is nothing but it is used to receive a wave with a power density, and it will be producing a terminating impedance, as well as we can calculate in terms of reciprocity or proportionality between PR and S. So in general, we can give it by an equation called as PR is equal to AE of S. So this is the aperture, effective aperture antenna. You can see in the diagram, which is nothing but ratio of available power at the terminals of the antenna to the power flux density of a plane wave incident upon the antenna, which is the polarization matched across the antenna. So if there is no specific direction that is being chosen, then the direction of the maximum radiation intensity is implied. So next one is beam width and directivity. Beam width and directivity is nothing but we can say that it is calculated as the antenna increases, as its beamwidth is made smaller, and the energy radiated into that particular concentration is made smaller solid angle. So next one is Friss formula. Friss formula, you can see this is how Friss formula works with this, that is a power radiated by the power transmitted, which is again given as lambda by 4 pi r the whole square dt naught and dr naught, which is nothing but the transmitted directivity and as well as the received directivity. So finally, let's see about polarization matching. So polarization mismatch loss is nothing but we can say in simple word, it is defined as the ratio of power received by the antenna and the power which would be received by the antenna perfectly that is being matched to the incident wave. So we have a formula for that. It is given in the slide. You can just note it down. So let me explain some few possible questions. Explain various antenna parameters, explain directivity, and explain Friss formula. I hope you all might have understood this video, and I hope you had a very useful session. Thanks for watching this video. Thank you.